years ago, my goodness, I'm old, I had the joy of speaking at a conference called JSConf US. Have we heard of JSConf by any chance?
Yep.
Fabulous. It is one of my favorite series of conferences around the world because it is a community conference in which a bunch of nerds get together to just like share their joy of programming, share their joy of collaborating, share their joy of learning and, being there for one another that in ways that go beyond just like our day-to-day work. And I had the joy there to speak and give a talk about how I built a Dance Dance Revolution mat out of some Node.js and some other components. I love playing around with hardware. You saw it.
I should have known.
Oh, no.
Nice one.
Oh, thank you. The reason my picture here is blurry, by the way, is because when I went to take a screenshot of it today, the JSConf US website was down, so I had to use archive.org's Wayback Machine to be able to get it. So fun fact, you still can look at old conferences, which is cool. You know what? I'm being rude. I'm sorry. Hi, my name's Ramon. My pronouns are he, him. I'm originally from Chile, but I've been living in Austria for 20 plus years now. Most of my work has been centered around different parts of the stack. I like to think of myself as a generalist. So I've been, I started out in Mac OS and Objective-C, and through today, I've just been like going all over the place. And it's just, there's such a joy that I find to collaborating in communities. And this is why I'm so happy to be here at ViennaJS. This is my second time at the ViennaJS meetup. The last time I was here was back in Sector 5, which those of you who are going like, ooh, yeah, that was a while ago. But it's such a joy to be here. I co-founded an initiative with my friend Jess called the Bad Website Club. And the vibe that I'm trying to portray to you here is that I think, a lot of the times we tend to get in our own way when it comes to being in programming and being in software development and being collaborative, which is what I find one of the most important parts of software development. I was just nerding about this earlier with some of the friends here. And I find this such a key integral part of just like letting go of oneself in order to be able to move forward and learn. And yeah, just being able to do this at a meetup is something that I find so special. So yes, that's enough of me humble bragging. Let's go into the talk. So cool. I was at JSConf US. It was my second time in the United States as an adult, it was my first time. Never mind. Anyway, it's 3-day conference, 2 days of talks, and 1 day they call it an activity day. Yeah. So they had a bunch of stuff you could do this was in Carlsbad, which is like Southern California. So there was opportunities to go kayaking. There was opportunities to go surfing. There was all of these kinds of outdoor activities that we could do. I chose staying inside and programming with some other friends. And so I took part in a workshop called NodeBoats, which is, as the name implies, programming boats with Node.js. So what you see here is some components. We've got an Arduino. We've got a Bluetooth module that communicates with your computer in order to be able to control the boat. How are we doing so far? Cool. So when I skipped ahead. So when I took part in this workshop, they gave us a bunch of parts. It kind of came in 2 parts. Not only did we have to build the boat out of materials, we also had to program it, which was a lot of fun. So they gave us access to a repository. They gave us some parts in case you're curious, because this was a lot of learning for me too. Despite having given a talk on hardware, I'm a bit of an imposter. I don't actually know all that much about hardware, but I'll share with you what I know. So we've got an Arduino here, which is a microcontroller. Okay, I don't see anybody disagreeing. Good. So that's a microcontroller, which is like a central processing unit that just like receives and runs instructions that communicate through these fancy wires with the other parts of our machine. We've got our little Bluetooth module here that's going to receive instructions, pass them on to the microcontroller. And then comes the interesting parts. We've got a servo. Do we know what a servo is?
Yep.
Cool. It's a thing that moves like on an axis like this. We're going to see why in a minute. We got an ESC. Did I write that down? I didn't. Electronic
Speed controller.
Thank you. Electronic speed controller. That's what I like about meetups. They're collaborative, see? So electronic speed controller, a motor, and a battery. And all of these communicating are going to be able to control our boat. The JavaScript parts comes in with Johnny 5. Have we heard of Johnny 5? Oh, cool. I get to tell you about Johnny 5. What it is a JavaScript runtime and series of modules and platforms and packages that allow us to be able to program robots mostly through Arduino for hardware. which again is was and still is relatively new to me. So being able to take part in this workshop was a lot of fun. So let's look at some code. So what we've got here is a script that we were given here that says, cool, connect to your board, which remember is that Arduino. We communicate with our ESC, which is all coming from Johnny 5 itself. So that ESC, remember, is a motor control. Says, cool, it's called forward and reverse. It communicates along these pins. Pins, let me just go back real quick here. Pins are the parts where the Arduino communicates with different parts of the breadboard. We good? So we send data to those pins. Sweet. And we've got our servo, which is set up. And then, as this very helpful comment here says, we just have to do the rest. So we were given a full day to work on this as we were split up into teams. And at the end of the day, we take part in a regatta. What a posh term, right? A regatta is kind of like, I'm going to sound really ignorant, a boat party for rich people? Is that, I think that sounds right. Anyway, so we would take all of our boats and we'd have like different competitions. And this was a picture from the day itself. You can see that people have different boats. We have like a race, we have an obstacle course, and we have a winner. So cool. I want to just take you on the journey of how that day was for us and how we thought or sunk outside the box. So we got to work on our boat. Our design was meant to have a pretty like speedboat kind of looking thing. We, of course, covered it in black because it had to look cool. We weighted it down, and I did none of this, by the way. My contribution was like, do you know what? This kind of looks familiar. I'm going to put a Batman logo on it. So we built our boat, we put the Batman logo on it, we covered it up, and then we had to give it a name. Now, given that it's a Batman boat, can anybody guess what the name of the boat was?
Boatman.
Boatman is a good guess. Batboat is close to. Bot.js? No.
Boatmobile.
Yes! Get this person a ticket, please. Because instead of the Batmobile, it's the Boatmobile. This was my second contribution to this project. And yes, I did bring a sailor hat to this conference halfway across the world just so I could pose for this picture. Anyway, we had our Boatmobile design ready. Now we had to get to work on our parts. Now remember, you can see it here. There's our Arduino, there's our ESC, there's our servo for the rudder. Does anybody know what a rudder is? Mm-hmm. So a rudder is for the back of the boat. It's kind of like, it's the thing that's kind of going like this. I'm doing a bad illustration. Pretend that I'm a boat. This is the part that does this so that when you're moving forward, it controls whether you go left or right. So the problem with ours, this is where the talk comes in. The problem with ours is that the servo was broken. So when we went back to talk to the organizers of the workshop and be like, hey, can we get another servo? We kind of had another idea. And I thought like, do we really need a servo for the rudder? What if instead of having a servo, what if we had two motors instead at the back? So what did we do? We made a fork. So now our code, instead of having an ESC and a servo, it was going to have two ESCs. And depending on the amount of power that each ESC puts in, it goes left or right. We built it. And here's a video of it running. It's the start of the video. Is there audio? You can hear one of our colleagues being like, don't tip her. So yeah, it worked. The other way we wanted to do it, and one part I should have mentioned, is that the template of the code came with, it ran in the terminal. It was a CLI that you can control with arrow keys, and it would send instructions, which was fun and all. But since we had a little bit more of an analog thing going on, why not use, come on, work with me. Why not use a virtual joystick on a web client? So we added a little bit of Express, added a simple JavaScript interface via WebSockets, and used a framework called Nipple.js to be able to, I didn't pick the name, to be able to have a joystick. So cool. Now we can connect. I think this is our front-end code. Let me verify that. It should be. Oh no, I should have read this, huh? Well, it's either the front end or the back end code. Anyway, we're connected via WebSocket. Oh no, this is definitely back end code. Sorry. Yes. So this is the receiving end of the web. So this is receiving data from that joystick that we are just sending raw via JSON into our Express app. Well, then we move the boat. The thing is, we move the boat. It's a little bit more complicated than that. Can anybody guess what's next? Linear algebra. So we put the laptops down for a minute, and I'm not even kidding. We got to work doing some like math that I haven't done since I was in high school. And I'm not even kidding. Like we were doing some cosines and stuff, like some trigonometry. I have never been so excited to do math in my life. And hey, we built our code. So we had speed from joystick. We got some data. Depending on the force, we would apply some force, some power to the left ESC and some power to the right ESC. Now, of course, you might notice the comment here be math because I haven't shown you the math yet because there's a lot of math. So depending on the amount of force and depending on the degree and the amount of power that's put into that side of the joystick, we calculate an amount of left force and right force to be applied to each motor. We don't need to follow this. I just want to illustrate that we did math and it was cool.
Did you get it right the first time?
Actually, we did. But that's because I didn't write it. So, cool. We coded up our boat. We went out to the pool for a testing. I don't know what happened here. My phone was like one of those early trying the fancy blurry thing. You know what I mean? Like the focus thing was trying like, anyway, we took it out to the pool. We set it up. We put our weights in. We loaded up our ESC. We took it out for a spin. And it worked. First try. My slides tend to be a little bit sassy. Just ignore that for a second. Cool. Yeah, it really worked. And I felt so excited to be able to take out a prototype and have it run and have it collaborate with me. And yes, it did sync. We had to replace some of the parts, which took me to an interesting thought experiment that I hadn't thought since high school again. Y'all ever heard of the ship of Theseus? Yeah. This is a thought experiment that comes about Theseus, who had a ship whose parts of those ship would start breaking down and he would replace parts of those ship, right? And so the thought experiment comes into, if you replace enough parts of that ship, at what point does it become a different ship or is it the same ship? Same happened to the boatmobile because we had to replace everything except for the, the actual materials. But it was a fun thought. It was nice to think about the ship of Theseus. The point of all this is that we had a really good time being able to do this. We, kept in touch. We still mess around with that bunch of code base. We still have videos from it. And the reason I'm here with you today to share this with you because I want to encourage you in your daily work, when you work around projects that have solutions that might seem like they fit a very narrow set of constraints, just once in a while, think outside the box. Because as for the boatmobile, well, it. Thanks, friends. So to answer that first question, is there a video of it syncing? No. Why would I show that?
Questions? Not really a question, but before we started, you were telling me about how you redid your slides last night or something like that.
No, like 5 minutes before the meetup.
It was absolutely worth it.
Thank you.
Always fun to listen to.
Thank you. That's very kind. That's the first, not really a question, but more of a comment question that went so positive for me. Thank you.
Still counts.
I think so too.
Just a simple one. Why you choose first of all 0?
Why do we?
Servo motor, servo.
Oh yeah.
Like initially you choose servo, but servo is used for precise work, right? Because it just moves. Like it's a small that moves.
Yeah. Why did we choose it?
Yes.
It was in the kit we were given. I mean, I wish I could say like, oh yeah, I had the same thought about how servos are too precise and all that. But to be honest, ours just didn't work, so we went with something else. So it worked out. Turns out we knew what we were doing after all.
More questions?
That one here.
Another question here. So, was that your own experience programming microcontrollers like Arduino with JavaScript?
Yes.
Or did you, okay. And did you also try something similar with other languages? And if so, how would that experience compare?
Oh, that is a good question. Well, as I said earlier in this presentation, I'd like to think of myself as a generalist. It's not really a microcontroller, but my first hardware experience is with Python and Raspberry Pi,
okay.
Which, it's just a different set of tools to do a similar or same job. I'm a big fan of like finding your way around a code base, emphasizing rather than on understanding everything 100%, but rather just like finding patterns that you recognize. Some of these tools that we use, look, I'm not gonna lie. This was 4 years ago. I have no idea if Johnny 5 is still around. Let's say Johnny 5 is no longer maintained and there's an alternative out there. At the end of the day, you still have patterns that you recognize that you can apply here. So in terms of experience, it's really choosing the right tool for the job. As you would say, oh, I don't know, a highly contested JavaScript front-end framework. That's not me throwing shade. I'm just giving an example.
Yeah, I mean, when you kind of show those like device or like IoT platform and JavaScript, I mean, those things are usually not combined together as far as my knowledge goes. So
yeah.
I understand this was like JS conference, so that was probably the constraint. So the question is like, have you done any production work or actually like client work which would combine the JavaScript and the device? Because that would be kind of interesting to know. Because again, when you say JavaScript, I'm already thinking web applications and not really devices. So
I should have given that presentation today. I have actually a presentation I've given on this stuff done for client work where I built a, now mind you, this was a long time ago, a cash register suite using Vue.js and figuring out how to have that communicate with a thermal printer, like ESC, if you're familiar with having it communicate with that, having two windows, because one is what the cashier sees, the other one is what the customer sees of what they're about to order. Figuring out how to have data concurrently synchronized between two browser instances, which if you're not, I just make code. Like I'm not, super like up to date on everything. So like figuring out a way to do that was a lot of fun. And again, it required, being a little bit inventive. We did eventually find a better solution that didn't require messing around with Vuex and like installing packages that are no longer maintained. But that's not the point. The point is that we had a prototype running that unlocked. I'm a big fan of like using inventiveness to unlock ideas. Like the way this is not really on topic, but I like to think of myself as somebody who like puts out a bad prototype so that much smarter people than me can go like, okay, this is why it's bad. And then it like, turns into actual production grade stuff.
What was it? Andreessen Horowitz? I can't find the quote, so maybe someone in the audience remembers what I'm saying. There's this quote from him saying, anything, the law of JavaScript, anything that any device or, what's it called? Medium can and will be run JavaScript on top of it. Anyone know the quote I'm talking about? Was I butchering it?
Yeah.
Anything that can be right in JavaScript will be right in JavaScript or something like that.
There you go. So smart minds have also reflected on it. And more smart minds than currently present have reflected on it.
I mean, that does apply much more before WebAssembly, but that's a different topic for a different day.
Maybe one last question?
Oh, yeah.
What caused the first book module to sync, and what did you change in the second one? Or still the first one with the same parts to not make it sync?
Yeah, that's
nice.
I mean, nothing against the other questions. They've been amazing, but that's a question that gets me fired up. So Actually, so the way I told the story, I misled you all a little bit because this isn't really a picture of us taking it to be tried for the first time, but this is us figuring out what was broken when it inevitably sank. And the problem came down to the weights distribution. So you see like the bottom of the boat, you can see there, like there's like a shape of a rock. So we had rocks inside there. And we just distributed them badly when we went to put it out in the pool. So once we figured that out again and used some like blue tack to like make sure the rocks stay in place while moving around like this, that made it work a lot better. Yeah, no, thank you for asking.
One last question.
Wait. So,
Oh, okay, so that's fine.
Do you know what?
Like I tell my kids, now.
This is the most questions I've ever gotten for a talk. This is great.
If you had a limited number of the motors, why didn't you put some kind of sables on the front and fight the other ships?
This guy has watched Robo Wars.
I have a few answers to that. First of all, Batman does not kill. Second, or so I'm told. I don't know much about Batman. And the other is, this was an MVP. Great question, though.
It would kill in production, is what you're saying.
I hold myself not liable.
So 2 small questions.
Please.
First one, so when I was trying to do something with IoT, the first thing I was thinking about, like, okay, I need to go down the electronics path. So I started to learn about electronics, like what are all the concepts. And I stopped in the books because it was like, okay, I will never be able to make the thing run. So how was, do you have any knowledge about all this electronics part, like the math behind it? And the second was, so as far as I remember, Arduino was not able to run any JavaScript. So was it a NodeBoats? Because there were some different microcontrollers that were able to run JavaScript. Do you know if that was some kind of a different one, or was it an Arduino running some emulator? Or?
So I believe. Oh, so let me step back because my memory is real bad. The first question was about electronics. Yeah, how do you consolidate that? And you know what? When you were giving your question, what reminded me of is what we talk to people when they're starting out in programming. Like, do I need to go all the way down to understand how a logic gate works in order to be able to program? And the answer to that is that, unfortunately, whether we like it or not, there are some parts where we're just gonna have to be like, do you know what? I'm gonna trust that it works. I'm gonna trust that V8 works. I'm gonna trust that Arduino and these pins know what they're doing. So we were given this diagram and we copied it to match. And of course, we experimented here. I'm a big fan of, I'm gonna nerd out. The constructionist theory of learning, which dictates that our learning is built upon each other as we go. So we take metaphors or patterns that we recognize in real life. So for me, for example, coming to electronics from a web background or from a programming background, I'm like, cool, what do I recognize as, for example, a module, a package that I can replace and have something else be there and communicate it with it accordingly? You've got power cables, I think, and a data cable. So I know how to implement those patterns and replace these things accordingly. And I think like understanding and leaving yourself little bookmarks of like, cool, from here, maybe I'll go and learn more about.
Like for the modular concepts, this is clear, but for me, like adding all the calculating all the circuit and the comparison, whatnot, what is there? Everything I forgot already. So
No,
this was already a little bit like all the numbers.
Not.
It seems like you were not even thinking about it. You were like,
No.
okay, I have cables, so I put them somewhere, and somehow it works.
I'm
and just write the JavaScript.
I'm a joyful dummy. I don't know what to tell you. No, but for seriously, I think like, that's of course understanding the constraints that we had for that day. We had something that works. We just went with it. If you are like, I know of a, how I was talking about logic gates. I know of a book called NAND to Tetris. Do you know this? It's an excellent resource, free resource on the internet, like a book for going from NAND, that is the logic gate, all the way to having an operating system that runs Tetris. And it's like, I think what we need to do is like look into or build educational materials that base on this, like, cool, if you are interested, let's take you down the journey to a accordingly let's say, simplified example that you can then apply all these metaphoric understandings to. There was a second part. I'm so sorry. I'm so sorry.
Okay, just trying to come up with
I can
something
do
witty
it,
to
yes.
come back.
We can
but
do it in private.
We can do it in private.
Okay.
I'm sure you can take this lovely conversation also
I'm here.
afterwards and then expand on it.
Thank you.
Thanks a lot. Give this one sponsor a stage.
So, hi everyone. It's good to be here. This is actually my first ViennaJS and first time speaking here. Yeah, welcome to the talk, Progressive Enhancement with SvelteKit, where we ask ourselves the question, what can go wrong? So, who is this guy who's standing in front of you? I'm a husband and father of 4. I was into robotics. I learned it in school and then made my hobby into my occupation, the web. I'm currently a web enthusiast at Voom bikes. So for all who have kids, probably know about them. I'm also a musician because with 4 kids, you still have a lot of time on your hands. And I'm also one of the founding members of Svelte Society Vienna, which will be in about 2 weeks. So I've heard that there are 2 kinds of people in the world. So by show of hands, who of you have used Svelte before? Cool. And the other ones are the ones that will use it in the future. Awesome. So I'll do a quick introduction on Svelte just to level the playing field here. So Svelte is a compiler, a framework, a language, depending on which part of Svelte you're looking at. It is very compact because it uses like the basic building blocks of the web, HTML, CSS, and JavaScript. So if you know any of those, you can build Svelte components, you can build Svelte applications because valid HTML, valid JavaScript, and valid CSS, they're valid Svelte code as well. It's also very complete, so state management, motion, forms, animations, all in a box because Svelte is a compiler. It just discards all the stuff that's not needed. There's also SvelteKit for apps. So for those among us who use React, it's the equivalent to Next. Or for those among us who use Vue, it would be Next. So SvelteKit for apps completes the picture. So Svelte itself is more for the components, and SvelteKit is for the applications. And the cool thing is you can deploy Svelte anywhere. So the way it works is you have your application, and then behind it, when you deploy and build your application, you can choose which adapter you can deploy to a bunch of serverless platforms. You can deploy to a normal Node application, or you could even write your own adapter, which wraps your whole thing into whatever wrapper you need for your environment. So let's jump into defining what progressive enhancement is all about. So maybe some ideas from the audience here. What is progressive enhancement to you? Include jQuery, okay, yeah.
So,
okay, yeah, that's a very good definition. So that's a very nice definition, actually. So having the basic building blocks of HTML, server-side rendered to your client, to the browser, and then build on top of that. So I just want to go through some points so we are all on the same page here. Progressive enhancement is a design pattern on how we build our apps so that they can fail in the most spectacular way, but still work and deliver value to our client. It is a design pattern to build more robust apps. It is a drive towards using the platform and the built-in stuff. And those patterns that help us, they are kind of, we can have our cake and eat it too. Patterns that support us in doing that are server-side rendering, so getting the HTML in its raw form to the browser. Forms are an integral part of progressive enhancement, and I'll show you how. And feature detection and polyfilling is also something that we can do to support and fall back to behavior that is supported among a multitude of browsers. So, demo time. First, we'll take a look at a progressive to-do, which is a really, really bare bone application on how we can work with SvelteKit and progressive enhancement. And then we'll take a look at Svelte Snaps, which was built by Rich Harris, one of the original creators of, well, the creator of Svelte among a lot of other maintainers. So, demo time. So, just to make this a little bit bigger and more friendly for the eyes, let's just start the dev server and then we can hide that away. So, by taking a look at our directory structure, most of the stuff should be pretty familiar. Static files, source files. All those other configuration files, we won't go into those, but hey ho. So in our source, we have our basic app HTML, which is kind of the HTML wrapper for our app, and we have our different routes. In our example, we only have one route, which is the root and nothing else. The way routes work in SvelteKit is with this plus.page, and then we have some plus page.server, which is server code that's running, and then plus.layout is, you guessed it, the layout that wraps this whole page. So a layout would be something for containers, headers, footers, but it's very bare bones, so we don't even have headers and footers in this example. In our Svelte server-side code, we have our hyper-secure database. Talk to me if you need any pointers. And then we have some actions, and that's it actually. Oh, we have a load function, sorry. Yeah, the load function, which returns the hyper-secure database. So those actions, we'll see that in a moment, are form actions where the server reacts to something that happens in the front end, and we have some very descriptive actions here. We have an add to do, check to do, delete to do. So looking at our front end page, we have like two different to do sections, which is very normal. We have our to-dos that are not checked, and then we have our to-dos where we want to display the to-dos that are checked. The cool thing is, so let's just take a look at the, well, let's jump into here first. Open it. So let's open the dev tools already because we'll need them in the future. So this is a very, very bare bones to-do app. We can add to-dos. So let's just open our network tab. If we add a to-do, speak at ViennaJS, and we add that, we see that there's a data request that goes out to the server. We see this add to do action that is taking place, and then we see our UI state update. The same thing happens again, of course. Eat, let's put some in, eat, drink, be merry. So I already drank something, so I can put that on the done to do check. So and maybe let's make this also a little bit bigger here. So we also see that we have like the check to do action that is triggered correspond to this check to do action that we saw in the code previously. So in our server, we have our add to do that we saw, we have our check to do, and we have a delete to do. And because I don't like shopping, I'll just remove that just to show that it also works. And we have our delete to do action called, and this whole application and UI state is updated. So why would we build the app in this way? Let's take a look at our to-do sections. So just remove that here a bit. So in our to-do section, we have our props declared here. We have our items, and we have our prop if it's checked or if it should not be checked. By default, it's false. So we can just override it pretty easily, like a little check if it's done to-dos, open to-dos for the headline. And then we have our list items, which are generated in each block. So those items themselves, so we need to go a little deeper. Oh, no, that's here. So those list items, they themselves are forms. And we see this little helper function, use enhance, which is all of the magic that happens behind the scenes in SvelteKit. Again, out of the box, we don't need to write that ourselves, which updates the UI state depending on what we do, and handles that gracefully without reloading the whole page. So if we write our application in that way, this enables us to do some really cool and crazy stuff. So if we go back to our application, let's hope, nope, that's not it. Control-Shift-P, yeah. Disable JavaScript. So now we are not running JavaScript. Let's just uncheck, because I'm kind of getting thirsty already. So uncheck this.
Okay.
We see the UI state still updates. We now have our page reload. And because we are handling this server-side rendering and reacting to forms and building on the fundamentals of the web, which is HTML, forms, server-side rendering. So now I drank something. I can check that again. So what we see here is that we load our root with this action, which is a form submission. And with that form submission, we handle in the server route, we handle the check to do. So the logic of talking to a hyper-secured database and updating all of the important fields for our to-do app. This runs server-side. Then the load function, which is part of the server-side rendering circle, is invoked. And then the page is just server-side rendered and returned back to the user. So you also see in the URL up here that we now are on the check to do. So with SvelteKit, we have a lot of tools given to us for free for building really, really stunning and die-hard applications. So they can run even without JavaScript and still be cool if we have JavaScript. So going to the second example would be Svelte Snaps. So let's make that also a little bit bigger. So Svelte Snaps is like a very basic Instagram clone. And you can do a lot of stuff when you're logged in. You can like different pictures. You can look. Oh, I think that. I'll just disable that. So we can like pictures. And as you can see, we can use this application even without JavaScript, although it is highly interactive with leaving comments, because we have the ability to I don't see the button. Out there, post. CSS bug. Yeah, so we see also the comment, and we could delete the comment again, and we could unlike the picture again. And this is all working because if we build our applications in a robust way, then they will also work with SvelteKit, even if JavaScript is disabled. And of course, if JavaScript is enabled, enable JavaScript again. It works, of course, a lot nicer. Dark mode is enabled for those of us who love dark mode. And we can have a more seamless interaction with the website. But we will always fall back to a robust application if something goes wrong, like if our network request for JavaScript fails, or if some CDN layer stuff goes wonky. So there are a multitude of things that can go wrong, but SvelteKit and Svelte, they have our back to build robust applications. So this was it. I hope you enjoyed the talk and got some inspiration and are eager to also build robust apps where users and applications fail gracefully and still work. If you want to take a look at the slides and stuff, feel free to scan the QR code. And now I'm open for questions. Yes.
That's a neat question, basically, because I actually don't see the point why this disabled JavaScript thing is a thing. Like with click, then HTML is using your site, it's pre-rendered, and the browser can already display. And as soon as you start interacting, JavaScript is loaded, and that's enhancement for me. So then JavaScript comes into play and can do stuff for me. Here, I don't see the point why I would have JavaScript disabled in the first place. That's not an enhancement for me. That's actually not a really safe scenario.
Yeah, so the idea is that JavaScript can fail because you are on a train going through the tunnel or whatever. So they're very unlikely for us scenarios where things can fail with JavaScript. So it's not necessarily the user's fault or the browser's fault. It might be just some weird stuff where the JavaScript is not loaded in a way it should be. And then to have your site function in a way that still works for all of the users as a fallback, but still have nice user interactions if JavaScript is available. That's also tricky. Yeah.
started typing the search bar, then
Yeah.
it worked. Or send it out. Doesn't matter. Like, of course,
Yeah, sure.
I think I asked the question, but
It's great. You don't have any JavaScript at all ever because like that's cool. You can make it work for them. But when they have JavaScript and they want to load, then it can be bad because like when they go on the site, they're on slow internet.
yeah, okay, so
They
that's the first thing. Yeah, but still, you have a huge application. Still a better enhancement to allow.
Yeah. Yeah, so the JavaScript won't break your site, like it won't break your interaction as soon as it's loaded. Maybe that was your question. Yeah. 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 Building on the basic of HTML and server-side rendering. Mm-hmm.
We suspend one of the libraries I did with the node. You can catch that and have that. But is the right supporting something too? Because the last one we got
Yeah. So a little teaser. The team is working really hard on Svelte 5 at the moment, and we already saw a teaser there some days ago. But for now, error boundaries in your SvelteKit application are kind of confined to the layout that you have. So if something inside, so you can have nested layouts, which would be kind of an error boundary. And suspense, the only equivalent that comes close to that would be you can load in your server code, you can return like a nested promise, which would be lazy loading the response of whatever you return. So you could have your database queries that take really long, suspended or awaited, and then magically filled on the browser side as soon as the data comes in. But the recommendation is to only do that for non-essential stuff. Mm-hmm.
way of doing things.
Yeah.
Everything cool and it's like, yeah, it's always nice if it works without JavaScript, but nobody really asked for it.
Yeah. So real-life scenarios, very good question. With server-side rendering and a functioning page without JavaScript, you usually have a way better SEO experience as well. Yeah. Yeah, but if you... Yeah. With Next, you kind of can. It depends on.
Bring the topic from framework discussion to what is the practical reason why I would need it. But like,
Yeah.
I don't know, customer X wanted it because of why. What is the why?
The why is it, like, depending on your business case, your website theoretically should work if everything goes wrong. Like, that's the idea behind it. Accessibility Yeah, forms also really accessible if you build them correctly. Small disclaimer.
That I could think of.
Yeah, I mean, you could even theoretically you could write patterns when you see a slow connection that you just say, we won't load JavaScript. Let's just fall back to the slow speeds, which might help some people. So it heavily depends on your user base and what you want to achieve. Yeah. Not for the stuff that. Yeah.
I'm sorry for
It's fine.
Yeah. Well, in this case, I was not delivering. So, for example, if you're government, there's people browsing the internet on Nintendo DSs, on web, but anything that's going to be for somebody that has the device that they can access the internet. So there's definitely cases where not supporting JavaScript is super important. In many cases, it doesn't matter. Like the application I developed, you don't have JavaScript, just nothing happens. But yeah, it's usually dependent on who your audience is and how important it is.
Yeah. If you're building for tech people, you won't have a problem usually. Yeah.
Be perhaps more useful than this? And if so, like what the solutions, the solution we just proposed include updates as well as like randomly when needed?
You could do optimistic updates. So maybe I didn't spend enough time on showing that. So if JavaScript is enabled, the page is not reloaded. So the request that is made, like the form submit, and then the update from the server, like it's a very, very small JSON payload, and then it updates your state. So you can have this granular update approach if JavaScript is enabled, which will be 99% of your case, like of the cases of websites that I usually build. Well, SvelteKit is the equivalent to Next, yes. Yeah. 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 So I. Mm-hmm. Mm-hmm. In my opinion, always 100% yes, because you tend to write less code and have like you don't need, like for animations and stuff, if you need those, you don't need a package, you don't need for state management, like that's all in the package of Svelte and SvelteKit. I've built applications with Nuxt.js. I'm currently migrating an application from Nuxt.js to Nuxt 3. I've built with AngularJS. I've built a little bit with React. And I also have, like for the Rewe world and for TU, I also built SvelteKit applications there.
Question?
what's the how much do you have to think about it? Something.
It depends. So for me, I don't really have to think about it anymore. Let's just give you some other numbers here. So the typical onboarding, so which I did for the Billa Vorbestell service. So I was the only one who was familiar with Svelte and SvelteKit, and I onboarded 3.5 developers, who were mostly working in the backend with C# before that. And I onboarded them in like 2 hours to a day until they were familiar with all of the concepts. So to get, like, independent of your background, if you have basic knowledge of HTML, JavaScript, and then CSS for styling, you can get like a team together and build something in 8 weeks, which we did. Even though the people were not familiar with the technology, we're all new to the technology, but we still managed to like build it from 0 to 100%. Mm-hmm.
I mean, if that is the case, then it's more web-centric stuff. It's flowing through to the browser. And that, so my question is, the example you gave of these actions, is that like the default Svelte way? And is Svelte very close to the web-centric?
That would be the recommendation from the documentation, yes. So they recommend to build the apps in that way, but you have the freedom to not do that as well. So your applications will work either way.